All right, let's make the screen a little bit bigger. Let's do a quick run through on how do you find information. So how do I find, this is Yuri holding. Say hi, Yuri. Yuri's holding the how do I find stuff for us. All right, on this chart, how do I find age? Well, you're given a star name. So the names of the stars are Sirius, Sun, it's a star that we know. Deneb, Polaris, that's the North Star. These are the stars. This is not where they're located in space. This is just a graph. Well, the age of the stars, there's three options. All of these stars are young stars. So they have low amounts of hydrogen. No, they have high hydrogen, low helium. The hydrogen is high in a young star. So early stage, anything in here is a young star. Anything in here is an intermediate star, middle-aged star. And then they turn into here. So 40 Eridani b is an old star. It ran out of hydrogen. It's got a lot of helium and it's turning into new elements. So the helium's starting to run down too. So a star like Sirius is going to do this change, and then it's going to do this type of change. So young to middle-aged to old. So how do the different things change as age changes, okay? How is luminosity going to change? What's the luminosity? Sirius's luminosity is maybe 20. There's no units. That's how you read that. What's going to happen to Sirius's luminosity? It's going to get more luminous. They get brighter as stars go from young to middle-aged. They get brighter, okay? But then it's going to get dimmer as it gets old. It's very sad. Yuri's really old. He doesn't give off any light. All right. How's the temperature of Sirius? Sirius's temperature to start off, more than 9,000 K. That's what Sirius is. As Sirius gets older and it turns into a star like Polaris, Polaris's temperature is cooler. Stars cool off for a little bit. They get brighter and cooler. But then, once Polaris turns into an old star, sort of like 40 Eridani b, hot, almost 20,000 K. Well, temperature and color are on the same side because they're the same thing. Hotter stars, Sirius is like a whitish color. Hotter stars are one color. When a star gets cooler, as it gets older, it gets cooler. Well, it's also going to change color. And then when it gets older, it changes its color again. So the hottest stars are blue and blue-white. And the coolest stars, like Betelgeuse, Barnard's star, Proxima Centauri, are red. So temperature and color are a match. Okay? Size. Stars start off, wherever they start off, as they get older, they're going to get bigger. This side over here is size. They're going to get bigger. And then when they get really old, they get smaller. They shrink down. So basically, when they start to expand, they cool off. And then when they contract and squeeze back together, they heat back up again. So that's how star information is read off of this chart. And that's how stars change over time. So different stars like our sun and Alpha Centauri are going to turn into stars sort of like Aldebaran. And then they're going to turn into white dwarfs, which are late stages. And you can see those changes as you watch the graph. Whichever way you're going on the graph, you just look at the proper side and you can get the information. Yuri, great job, pal. Keep up the good work.